So in this video, we're going to look at an example where we use the log rule for integration in an example that involves a definite integral. So here I have the definite integral from 0 to 1 of x squared over x cubed plus 1 dx. And the important thing to recognize is that the derivative of the denominator varies from the numerator by only a constant. So the u substitution, u equals x cubed plus 1, is going to be sensible. So then if we take the derivative with respect to both sides, we get du dx equals 3x squared. And again, the 3x squared differs from the x squared here by only the constant 3. So next step, I'm going to multiply both sides by dx and multiply both sides by 1/3. So multiply both sides by 1/3 dx, which will give us by algebra 1/3 du equaling x squared dx. And then once you do that, you're ready to make your substitution. So we're going to get the integral, and it's going to be 1 over u because we're going to replace x cubed plus 1 with u. And then we're going to get a 1 here in the numerator because we're going to replace the x squared dx, with 1 over 3 du. So there's the du. And 1/3 is a constant and can be factored out in front of the integral. And now I'm going to go ahead and change the bounds of integration. So from the original integral, we know that x runs over the closed interval from the lower limit of integration 0 to the upper limit of integration, which is 1. So when we do the u substitution, u equals x cubed plus 1, u is going to run over the interval from 0 is going to go in for x, because this is the interval x is an element of, so we're going to get 0 cubed plus 1. So u is going to run from 0 cubed plus 1 to plug in the upper bound of integration, 1 cubed plus 1. And then these simplify to u running over the closed interval from u cubed plus 1 is 1, and 1 cubed plus 1 is 2. So we're going to run over the closed interval from 1 to 2. And by changing the bounds of integration, we won't have to substitute x cubed plus 1 back in for u after we integrate. Now I have the form u prime over u. So the antiderivative is going to be 1/3 the natural log of u from 1 to 2. Note I don't need the absolute value on the sign because over the closed interval from 1 to 2, u is always positive. So this is a case where I could have put the absolute value symbol, but I don't need to. And now we're going to use the fundamental theorem of calculus to evaluate this the rest of the way. We know that we plug in the upper limit of integration minus, and then we plug in the lower limit of integration, and we're going to get 1/3 times the natural log of 2 minus 0. So the natural log of 1 is 0 because the exponent you raise e to, which is the base for the natural log, to get 1 is 0. E to the 0 equals 1, so natural log of 1 is 0. So we wind up just getting 1/3 times the natural log of 2.